Dr. Bbosa science, kwano kwa beti science, rafu ya Bbosa science, truth na beta, truth na omega, truth na alpha science.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Ssomero lya Dene Boarding ery'abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Our teacher today is Dr. Bbosa Science. Dr. Bbosa is a teacher at the Science Foundation College. Today we are going to study alkanes. Alkanes are saturated hydrocarbons with a general formula CnH2n plus 2. Examples: when N is 1, the compound is CnH2, the name is methane. In methane, each hydrogen atom is bonded to a carbon atom by a single bond. Also notice that in alkanes, name end with ANE. Name end with ANE. Example 2 is ethane. C2H6. In ethane, carbon is bonded to carbon, and each carbon is bonded to 3 hydrogen atoms by a single bond. Example 3, when the carbon atoms are 3, hydrogen is 8. The name is propane. In propane, carbon is bonded to carbon by a single bond. And this carbon is bonded to hydrogen atom to make 4 bonds. Example 4, with C4H10 we can write 2 compounds. The first compound is butane, where carbon is bonded to carbon by a single bond in a continuous chain. Or the 2-methylpropane, where we have carbon bonded to carbon, and then a branch of a methyl group. Compounds with the same molecular formula but different structural formulae are called isomers. Therefore, butane and 2-methylpropane are structural isomers. Isomerism is the existence of compounds with the same molecular formula but different structural formulae. When naming alkanes, the rules to be followed. Straight chain compounds are named according to the number of carbon atoms in the chain. For example, 1 carbon atom, methane. 2 carbon atom, ethane. 3 carbon atom, propane. 4 carbon atoms, butane. 5 carbon atoms, pentane. 6 carbon atom, hexane. 7 carbon atom, heptane. 8 carbon atoms, octane. 9 carbon atoms, nonane. 10 carbon atoms, decane. Chiral groups. These are alkanes minus 1 hydrogen atom. For example, CH4 is methane, CH3 is the methyl group. We can have ethane, C2H6, then C2H5 ethyl group. We can have propane, propyl group, butane, butyl group, pentane, pentyl group, hexane, hexyl group, and so on. Naming branched alkanes follow the following rules. Rule number 1, count the carbon atoms in the longest continuous chain and number the carbon atoms from the side nearest the branch. For example, in this compound, the longest continuous chain contains 1, 2, 3, 4 carbon atoms. The name is butane. Then we number from the side nearest the branch. So we are going to number from this side. 1, 2, 3, 4. On carbon number 2, there is a methyl group. So the name is going to be 2-methyl butane. The name is going to be 2-methyl butane, and it is one word. Rule number 2, if an alkyl group appear more than once on the parent alkane, use di, tri, tetra to indicate the number of such groups on the parent chain. For example, this compound has got 2 methyl branches. So the first rule says number from the side nearest the branch. 1, 2, 3, 4, 5. 5 carbon atom in the longest continuous chain. The parent name is going to be pentane. On carbon 2, there is a methyl group. On carbon 3, there is a methyl group. So the name is going to be 2, 3, dimethyl pentane. At position 2 there is a methyl group. At position 3 there is a methyl group. So there are 2 methyl groups. So the name is going to be 2,3-dimethyl pentane. Meaning that at position 2 of pentane there is a methyl group. At position 3 there is a methyl group. So 2,3-dimethyl pentane. Between a number and a number you put a comma. Between a number and a letter you put a dash. Between a number and a letter you put a dash. Rule number 3, if there are different branches, name them alphabetically. For example, this compound has got 1, 2, 3, 4, 5 carbon atom in the longest continuous chain. It has got a branch which is a methyl group. This is a methyl group. It has also got a branch which is ethyl group. We are told to number from the side nearest the branch, so we shall number from this side. 1, 2, 3, 4, 5. So the main name is going to be pentane. On pentane, at position 2 you have got a methyl group. At position 3 you have got an ethyl group. But the rules say if there are different groups, then name them alphabetically. So the name is going to be 3-ethyl, then 2-methyl. So the name is going to be 2-ethyl, 2-methyl pentane. Between a number and a letter you put a dash. Rule number 4. If branching occurs equal distance from either side of the chain, choose the name that gives the least sum of combination of numbers. For example, the parent chain has got 1, 2, 3, 4 carbon atoms, so the main name is butane. Branching will occur on the second carbon atom from either side. If we number from this side, 1, 2, 3, 4, the name is going to be 2, 3, 3, the name is going to be 2, 3, 3, trimethyl butane. If we number from this side, it is 1, 2, 3, 4. The name is going to be 2, 3, 3, trimethyl butane. If we number from this side, then we shall have 1, 2, 3, 4. The name is going to be 2, 2, 3, trimethyl butane. The rule says choose a name with the least sum of combination of numbers. Let's sum up the numbers. Here we shall have 2 plus 3, 5 plus 3, 8. Here we shall have 2 plus 2, 4 plus 3, 7. So choose a name with the least sum of combination of numbers. The sum of these numbers is 8. The sum of this number is 7. The correct name is 2,2-trimethyl pentane. Properties of alkane. They are insoluble in water. They are soluble in organic solvents. They are good solvents themselves. They range from gases, liquids, and solids. An example of a gaseous alkane is methane. An example of liquid alkane is paraffin. An example of solid alkane is candle wax. Chemical properties of alkanes. Alkanes are generally unreactive because they form a strong carbon-hydrogen bond. However, under drastic condition, they can react. For example, one, they burn in oxygen to give carbon dioxide, water, and heat. For example, methane plus oxygen will give you carbon dioxide and water. Because they produce heat, they are used as fuel. 2, they react with chlorine to form chloro compounds. For example, methane plus chlorine will give you either chloromethane, dichloromethane, trichloromethane, or tetrachloromethane. Mechanism is the sequence of events from the reactants to the product. Mechanism tells us which bond breaks first, which bond breaks next from the reactant to the product. In other words, a reaction is the breaking and formation of a bond. The sequence of bond breakage and formation is what constitutes a mechanism in organic chemistry. So in this case, chlorine will dissociate to form chloro radicals. In other words, in chlorine molecule, they are bonded by a covalent bond where they are sharing electron. In the first step, this bond here separate. So you get In the first step, the chlorine molecules separate at the bond. Each chlorine atom takes one electron. It contributed to form this bond. So an atom with unshared electron, like this one and this one, is called a free radical, and this electron which is not shared is indicated by a dot. In other words, we are using a half arrow to carry one electron to this atom and one electron to this atom to form a free radical. This is a free radical. A free radical is indicated by a dot on the atom. You can put a dot anywhere you want. The first step, the chlorine molecule, which is formed by sharing a pair of electrons, separates to form a chlorine atom and a chlorine atom. In the chlorine atom and the chlorine atom, there is unshared electron. That unshared electron is indicated by a dot on the atom. Indicated by a dot on the atom. Any atom with unshared electron is called a free radical. And any atom with unshared electron is called a free radical. So a chlorine molecule will dissociate to form two free radicals. Therefore, a chlorine molecule dissociates to form two free radicals in the first step of the mechanism. The second step, chlorine free radical reacts with methane to form a methyl free radical and HCl. One electron is biri, hydrogen yagirese, carbon yagirese. Hydrogen electron yagirese na chlorine is forming HCl. Electron carbon yagirese ne sigara to make a methyl free radical. Step 3, a methyl radical reacts with chlorine to form chloromethane. A methyl radical reacts with chlorine to form chloromethane and a chlorine free radical. Step 4, chloromethane reacts with chlorine free radical to form chloromethyl free radical plus HCl. Then chloromethyl free radical will react with chlorine to form dichloromethane plus chlorine free radical. In step 6, dichloromethane will react with chlorine free radical to form dichloromethyl free radical plus HCl. In step 7, dichloromethyl free radical plus chlorine will give you trichloromethane plus chlorine free radical. In step 8, trichloromethane reacts with a chlorine free radical to form trichloromethyl free radical plus HCl. And then step 9, trichloromethyl free radical reacts with chlorine to form tetrachloromethane and chlorine free radical. Because the mechanism proceeds by formation of free radicals and one step leads to another, the mechanism is described as free radical chain reaction mechanism. Free radical chain reaction mechanism. Then we can have terminating steps or reactions which consume free radicals will stop continuation of the reaction and they are called terminating steps. For example, terminating steps. These are steps that consume free radicals. When the free radicals meet, they form molecules and there will be no further reaction. So chlorine free radical plus chlorine free radical will give you chlorine. Methyl free radical plus chlorine free radical will give you chloromethane. Methyl radical plus methyl radical can give you ethane, and so on. There are so many reactions which are taking place at terminating steps. Terminating step will stop further reaction. Sources of alkanes, we have petroleum deposits, for example those from Bunyoro. You can also get it from biogas. Biogas is produced by anaerobic decomposition of organic matter in the presence of water. The organic matter can be cow dung, feces, dead animals, and so on. 3. By cracking of long chain hydrocarbon compounds. Cracking is the breakdown of long chain hydrocarbons into short chain hydrocarbons by heat, thermal cracking, or by catalytic cracking.
Omukyala kyakufumbira kyolya, omukyala kyakufumbira kyolya, naye lwaki mono ku moto womala kuyomba, mono ku moto womala kulwana, mono ku moto wotujereka, lwaki wangana okulya mu kyalo, lwaki woza simalako olimba, olusi wogifumbira waba kulwaza, olusi wogifumbira waba wakyamu, omulungi atanabakanyiwa, n'obutayoza kiba kikyamu, entikko y'omukwano kisenge, lwaki naye lwaki mono ku moto womala kuyomba, mono ku moto womala kulwana, mono ku moto wotujereka, lwaki wangana okulya mu kyalo, ofumba okwagala lisaaki okunyuma, wange nsiba mu lisaaki, mondo okumukutandwawo, mondo okumunyima ntabuka, mondo okumusima kuba, mondo okuwomerwa kiva ku mazzi, wetegekere muno, nfunira akaseera akamala, ozanyisa omutwe ogwanyumirwa, wagazanyisa mipiira anyumisa, zanyisa baluni, zanyisa amabeere, lusinyoka n'okuyonka anyumirwe, faayo omukwano gwagala kuyiya, ofumba ogwagala lisaaki okunyuma, wange nsiba mu lisaaki, bweruba oluganda nsobola okuwasa omukyala abawuwo, njagala omukyala abaawo, betita yombayomba, betita nyiganyiga, betita ganagana, bw'oyagala akawunga abaawo, bw'oyagala omuceera abaawo, ennyimba z'omupiira asobola, anyumisa, nyumirwa omukwano gwe, mono ku moto womala kuyomba, mono ku moto womala kulwana, mono ku moto wotujereka, lwaki mono ku moto womala kuyomba, mono ku moto womala kulwana, mono ku moto wotujereka, lwaki